Dear students, today we will continue chemical bonding. That is the part of the chemical bonding we are going to discuss by taking the electron dot and orbital concept. Today I will take another example of molecules. Today I am going to discuss the first example, NO2. See the NO2. This NO2 molecule, how formed, that I am going to discuss. You know the structure of NO that I have discussed already. There is an odd electron on nitrogen and a lone pair of electron on nitrogen, and on oxygen there you get two lone pair of electrons. This is the structure of NO molecule that you know. If I do add oxygen with NO, you will get NO2 molecule. You know oxygen, there are 4 available orbitals, valence orbitals 4, and the available electrons that are 6. I'll put 6 electrons in 3 orbitals. My intention to make one orbital is vacant to form a bond. Now, you know one occupied orbital of nitrogen which is electropositive, and with respect to oxygen, that's why nitrogen lone pair is better donor with respect to oxygen. Now nitrogen will donate its lone pair to the oxygen vacant orbital, and there will form a sigma bond where nitrogen will get positive charge, formal charge positive, and oxygen will get negative charge, that you got idea from the previous class. And finally NO2 already formed. O double bond N, single bond O, and you know donor nitrogen will get positive charge and acceptor oxygen will get negative charge. And neutral bivalent oxygen, there will get 2 lone pair of electron. I am not drawing the orbital. Here you will get an odd electron that is remaining like NO, and oxygen 6 electrons in 3 orbital. This is the structure of NO2, where the middle nitrogen formal charge +1 and this terminal oxygen will get minus charge or negative charge. Now, if I take this canonical form, this is oxygen number 1, this is oxygen number 2. What is the observation from the structure? This nitrogen oxygen double bond, this length should small. Here nitrogen oxygen single bond, the length should more. But remember, experiment will show you both nitrogen oxygen bond lengths are same. How you will explain it? Let it is thus one canonical form, one structure. You can do another structure or canonical form that is called resonance. I can make pi bond with this oxygen and automatically break it, otherwise no vacant orbital generate on nitrogen. And you will get another canonical form. This left oxygen will get minus or negative charge, this nitrogen get positive with odd electron, and this becomes double bond with 2 lone pair of electron. This is another canonical form. And see these 2 canonical form, both are equally stable, both have equal in energy, and the actual contribution of NO2 molecule is the average of these 2 canonical form. That average you can draw by this way, that is O single bond nitrogen, single bond nitrogen, that sigma are fixed, but the pi bond 50% with oxygen 1 and 50% with oxygen 2. And you can do average, that is 50% pi bond with left oxygen, 50% pi bond with right oxygen, and in both 2 canonical form, nitrogen here positively charged, minus charge also equally distributed among the 2 oxygen atoms. That's why the formal charge of each oxygen is minus half, minus half. This is the resonance hybrid structure of NO2, and which will give idea that 2 nitrogen oxygen bond lengths are same. Formal charge on middle nitrogen is +1, terminal 2 oxygen atoms with minus half charge. And one thing here important in the NO2 structure, any one canonical form will take in for our purpose. In NO2 structure, here the effective number of electron, here also the effective number of electron around nitrogen count. There are 3 bonds, that means 3 into 2, 6 number of electrons, and 1 odd electron on nitrogen, that is total 7 electrons. This is also less than octet, and this is odd electron molecule, and you know if there are odd electron, then it will be the paramagnetic. That means NO2 molecule is a paramagnetic. Not only that, due to this odd electron, its color is brown. Its color is brown also due to this odd electron. Now, like NO2 also try to make its octet. Now I will show you how it will make octet of nitrogen. Effective number of electron nitrogen, how it will come 8. That I am going to show you. Now, the most easiest way NO2 can become a octet molecule, nitrogen effective number of electron, you will get octet. The easiest way is this. Nitrogen, you know the basic structure. This is oxygen, this is oxygen, this is negative charge with 3 lone pair of electron, and this oxygen neutral always 2 lone pair. Here you will get an odd electron with plus charge. It can easily accept an electron from outside. That means it can easily reduce. If this oxygen, this nitrogen accept this electron, what you will get? The formal charge of nitrogen becomes 0, and it is double bond O. This is single bond oxygen with -1 charge, and it becomes, here you will get a lone pair of electron. 1 electron comes from outside. Now it becomes neutral. See the structure, and the species is the well-known species, that is nitrite radical NO2 minus. And in NO2 minus, nitrogen octet is completed. Oxygen always octet complete. All have 8 electrons. All atoms have effective number of electrons are 8. The species is NO2 minus, and this radical is common radical in inorganic chemistry. And remember, when it becomes the octet, then its paramagnetic character is lost. That means NO2 minus is a diamagnetic radical. It is a diamagnetic radical, and also its color is colorless since there is no odd electron. Another point is important. Let it is oxygen 1, this is oxygen 2. Here also you will get another canonical form which will give you, this is single bond, this is double bond, and with 2 lone pair, here 3 lone pair with -1 charge, and on nitrogen you will get lone pair 0 formal charge. These 2 canonical form are identical and they have equal energy. Here also you can draw the hybrid structure of NO2 minus radical. That hybrid will tell you 50% pi bond with left oxygen, 50% pi bond with right oxygen. Here lone pair is fixed with 0 formal charge. Here you will get minus of, this is minus of. That means in NO2 minus radical, both nitrogen oxygen bond lengths are same, and it is stable, and bond order. Bond order means number of bond between nitrogen and oxygen is 1.5, and all atoms here will get octet. That's why NO2 can easily form NO2 minus by accepting electron. That means NO2 can reduce easily to NO2 minus, and that radical is available in our chemistry, mainly in inorganic chemistry. I'll show you the another way by which it will get octet. See the magic, how oxidation also gives the octet of nitrogen. If you remove this electron, that is oxidation, you know. If you remove this electron, what you will get? You will get this N, this is double bond O, you know. Then you will get 2 lone pair, neutral oxygen. This is oxygen minus with 3 lone pair minus, and here no electron. It was plus, now 1 more electron removed, that means it becomes 2 plus. But you know it is irrelevant structure, highly unstable. Immediate this oxygen will donate a pair of electron and will make a pi bond with nitrogen. And finally what you will get? Oxygen, double bond oxygen, 1 plus charge is neutralized, 1 plus charge is neutralized, and this vacant orbital also involved to form pi bond with this oxygen, and you will get NO2. This is the structure of NO2, and see both nitrogen oxygen bonds are double bond. That means here the bond order is 2, and bond order greater than previous NO2 minus. That means if one question will come, compare the nitrogen oxygen bond length between nitrogen oxygen bond length in NO2 minus and in NO2 plus, then always in NO2 plus there are double bond, its bond length is less, and in NO2 minus bond length is more. There you got the bond order 1.5. And this radical also available in chemistry, since both nitrogen and all oxygens will get octet. So what you got idea? NO2 is a neutral molecule, NO2 is a brown color gas. You know, due to odd electron it is paramagnetic. NO2 can easily form NO2 minus by accepting one electron, and where all atoms will get octet. NO2 can easily oxidize to NO2 plus, where also you will get octet, and bond length reduces in NO2 plus. Bond order between nitrogen and oxygen is 2 in NO2 plus. I will discuss another way by which it may get octet. Now I will take another way by which nitrogen will get octet from NO2 molecule. That structure of NO2 already you know, there is an odd electron on nitrogen. That odd electron, this is odd electron I am drawing, this is NO2. Take another NO2 molecule. Here also you will get an odd electron. Now they form dimer. You know, in liquid state, NO2 will form dimer. This one electron shared by two nitrogen atom of two different NO2 molecule, and you will get N2O4. That is the dimer of NO2. In liquid state, majorly NO2 exists as N2O4. Now, if I draw the clear picture of N2O4, there you will get NN sigma bond. You know, one double bond with oxygen, single bond with oxygen, single bond with oxygen, double bond with oxygen, and double bonded oxygen, you know, with two lone pair of electrons, single bonded oxygen with three lone pair of electrons with formal charge -1, and here two lone pair neutral oxygen. Single bonded oxygen is O minus like halogen with -1. This is the structure of N2O4. This N plus O minus, you can draw also the coordinate bond. That means you can put arrow, but better presentation is plus minus. Here both oxygen with +1 charge, but you know, according to resonance, if I take another canonical form, this oxygen -1 charge equally distributed among the two oxygen, that means -1, here also -1. One thing is important. When NO2 form dimer, then odd electron gone. If odd electron gone, it becomes diamagnetic. That means in liquid state it is diamagnetic when it will form dimer. Not only diamagnetic, it becomes colorless, since you know the color of NO2 due to odd electron. Now odd electron gone, it becomes colorless. Colorless. No color you will get. What you got? NO2 is odd electron molecule. It can form NO2 minus, it can form NO2 plus, it can go through the dimer, that means N2O4. Now I will discuss another example. See, N2O, you know laughing gas, N2O nitrous oxide, which is laughing gas. N2O. See how I will form this simple molecule N2O. You have idea about N2 molecule? I have formed there N2, N triple bond N, 3 orbital involved in the bonding, 1 orbital remaining with a pair of electrons, since you know the valence electron of nitrogen is 5. Now N2 I will add 1 oxygen atom. By similar way, oxygen I will take 4 available valence orbitals and 6 electron. I will put 6 electron in 3 orbitals. I will make 1 orbital vacant to form this bond. Now nitrogen is donor, oxygen is acceptor. You got N2O. And a structure will come like this: N triple bond N, donor nitrogen, tetravalent nitrogen always with plus charge, and this oxygen is -1, and here you will get 3 lone pair of electron. Oxygen when -1, always there you get 3 lone pair of electron like halogen, and this is neutral nitrogen with 1 pair of electron. This is the structure of N2O. You can take another canonical form. You can make pi bond with oxygen. Then you have to break this bond, since this nitrogen plus has no available orbital to form the bond. You know the orbital is the essential criteria to form the bond. Now the terminal nitrogen becomes minus with 2 lone pair of electron. This is minus, and double bond nitrogen and double bond oxygen. Oxygen becomes now neutral, and middle nitrogen always plus 1 charge. Another structure of N2O. See, here plus charge is fixed in both canonical form, but the minus is distributed equally, not equally here, since the both atoms are different. More negative you will get on oxygen, since it is electronegative. Less negative you will get on nitrogen. You can take both to structure to get correct idea about the N2O molecule, which is laughing gas. Now I will make another molecule from this N2O. I told you many times the isoelectronic and isolobal. Isoelectronic means equal number of electrons. Isolobal means equal number of available orbitals. You know N plus available orbitals 4, N plus available electrons 4. That means you can structurally replace N plus bicarbon. I'll replace N plus bicarbon. And right side oxygen make fixed oxygen. Now N minus, which has 6 electron, like oxygen. That means I can replace N minus by oxygen. And you got magically, you got the structure of carbon dioxide. This is carbon dioxide. That means structure of CO2, structure of N2 are similar. Another structure I will draw which is complicated. You will get later in P block azide ion. See how I will form the azide ion simply from this N2O laughing gas. See, middle nitrogen remains same plus. This is double bonded nitrogen minus with 2 lone pair of electron minus. Just here I will replace oxygen by N minus. We replace oxygen by N minus. See what you got. This is N3 minus. Azide radical you got simply. Azide radical. This is also a pseudo halide ion. Here the nitrogen bond order is 2, and it is isoelectronic with N2O, isoelectronic with CO2. That's why all have similar structure. That means so many molecules you can form easily by taking the isoelectronic and isolobal concept. By taking isolobal and isoelectronic concept, you can draw the structure of different molecule. I will draw a structure of a radical NO3 minus, important radical, nitrate radical. See, NO2, you know the structure already. I have discussed about NO2. There is an odd electron, NO2. And I will draw NO3 minus. That means add with O minus. O minus, there are 4 orbitals and 7 electrons, like halogen. O minus, put 7 electrons. 7 electrons. This is O minus. Make a normal sigma bond, normal bond, where both nitrogen and oxygen shared by 1 electron each, and you will get the structure. See, NO2 structure that you know already, it was 1 O minus. This was double bond oxygen, and you got another oxygen with minus charge, and O minus I told you always 3 pair of electron, 3 lone pair of electron, and neutral oxygen always 2 lone pair, and tetravalent nitrogen is plus. This is the structure of NO3 minus, important radical. You know NO3 minus will give Brown ring test. It has Brown ring test, identification test. Now remember, like previous, here also you will get different canonical form. You can make this is double bond, this is single bond. Another canonical form you can get, that is N double bond oxygen, this 2 oxygen minus. You can make this is double bond, this is minus. 3 equivalent canonical form, that is resonance you will get, and all have equal stability. Actual structure of NO3 minus is the average of these 3 structure, and when you will go to take average, The 1 pi bond, you know this pi bond equally distributed among the 3 oxygen. That means actual structure is oxygen, 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 1/3 pi bond, 1/3 pi bond, 1/3 pi bond, and see here 2 minus charge on oxygen equally distributed among 3 oxygen. That means the formal charge on oxygen is -2/3. Here also -2/3, and all nitrogen oxygen bond lengths are same, and bond order, that means number of bond, that is 1/3. You got idea about the NO3 minus radical structure, and all nitrogen oxygen bond lengths are same here. Now I am going to take a simple example. Ammonia, you know, nitrogen, there we get 3 sigma bond with hydrogen, that means 3 orbitals involved to form the hydrogen bond with the hydrogen, and there will get 1 lone pair of electron. All 4 orbitals, 3 orbitals involved to form sigma, 1 you will get lone pair of electron. Now I will form another radical, that is H plus. NH4 plus I will do form, and H plus has a vacant orbital only, that is 1s, you know. Now look, nitrogen lone pair donor, H plus acceptor, and in the acceptor we will get minus charge, minus plus it becomes neutral, and nitrogen will get plus charge. Now you got a radical, that is ammonium ion. See the ammonium ion, the structure, all nitrogen, hydrogen are sigma, and formal charge on nitrogen is plus. What is the main point here? See, the normal valency of nitrogen is 3, and the normal valency when nitrogen 3, then the formal charge on nitrogen is 0 with 1 lone pair of electron. It can extend its valency one and only way by donating its pair of electron. And when it will donate a pair of electron, then automatically the formal charge on nitrogen will come plus. Remember this here, plus on nitrogen without any vacant orbital, without any vacant orbital. The point is important. When I will discuss in organic chemistry, electrophile, nucleophile, actually plus, normally we have concept is electrophile. But here nitrogen plus charge, it is never access electrophile. Condition of electrophile is available vacant orbital. Remember here the plus charge without any vacant orbital. Now simple another, what are you know? Oxygen, that its normal valency 2, and it will make 2 number of sigma with 2 hydrogen with 2 pair of electrons, since total number of electron around oxygen is 6. Now it can extend its valency also, it can form hydronium ion. H plus has one vacant orbital, that you know, and on oxygen will donate its pair of electron to H plus, and you will get hydronium ion, H3O plus. You will get plus on oxygen, since oxygen is donor, and with a pair of electron on oxygen. Now question may arise, this oxygen can make another sigma bond with hydrogen? Never. Remember, when formal charge on oxygen is +1, it becomes highly electronegative. It becomes more electronegative than fluorine. Plus charge always increases the electronegativity, and this lone pair is tightly bounded by the nucleus of O plus. And due to tightly bounded by the nucleus of O plus, this lone pair is highly inert. Never it will form any kinds of bond apart from hydrogen bond. Since you know when it will go to form hydrogen bond, 100% contribution is not required. That's why this lone pair can form only hydrogen bond. Never it will form any sigma bond. Now I will take another example. You got idea? Trivalent oxygen always plus charge, and tetravalent nitrogen always plus charge. Now I will take another simple example, that is carbon monoxide. You know carbon monoxide, carbon and oxygen, carbon valency 4, oxygen valency 2. I will take limiting valency, put limiting valency. Oxygen remaining orbital 2, 4 electron, put 4 electron into orbitals. But carbon also available orbitals, remaining orbitals 2, and there are 2 electrons remaining. According to Hund's maximum multiplicity, each orbital with 1 electron will get more stability. But see, I will bring this electron, I will put both 2 electrons in a single orbital. What is the profit? You can form a bond. Oxygen donate, carbon acceptor. If carbon with singly occupied orbital, then it will never form any bond with fully occupied orbital. That's why I make it vacant by taking this electron. Now you will get structure of carbon monoxide. See the structure, acceptor is minus, donor is plus. You will get their carbon, oxygen triple bond, oxygen plus donor with a pair of electron, carbon acceptor with minus formal charge. This is the actual structure of carbon monoxide that you know, which is poisonous. Now I am going to give another idea. You want to form CO plus is a radical. Now I'll form CO plus. How? See, if you remove one electron from CO molecule, you will get CO plus. Now the question will arise, sir, from where I will remove that electron? You know this is carbon minus, this is oxygen plus. I told you oxygen plus is much more electronegative, that is more electronegative than fluorine. Whereas carbon electropositive, even there are minus, carbon is electropositive like metal. That means you can easily remove electron from carbon end. To remove electron from carbon end, you will get carbon with single electron. Here it is plus charge with a pair of electrons. See, here number of bonds between carbon and oxygen 3, that is bond order 3. Here also 3. Now if question will come in future to compare the carbon oxygen bond length, what will be your answer? Since both bond order 3, remember here carbon with minus charge, that means electropositive. Here carbon is neutral, that is electronegative. And you know with increase of electronegativity, bond length decreases since its attraction towards bonded electron increases. That means bond length, if question will come in future, bond length, CO bond length, of course CO bond length, in CO plus less than CO, although both bond order are 3 from the structure, only its electronegativity will decrease a little bit the bond length. Now I'll take another example, critical example. Isocyanide and cyanide. See my drawing. Methyl cyanide. Carbon valency 4, make 3 bond with hydrogen, and remaining 1 valency make bond with carbon. Its remaining valency 3. This is cyanide and nitrogen neutral with a pair of electron. Carbon has no lone pair of electron. Now I will form isocyanide. How we will convert it into isocyanide? See, it is difficult to draw isocyanide. Maximum students have confusion. What is the structure of isocyanide? Isocyanide means NC. Put a nitrogen. Its valency is saturated now 4. Nitrogen valency 3. 1 completed. Put another 2 bond with carbon. Now the one by similar. It has lone pair of electron and carbon has 2 orbital. Make 1 orbital vacant. Now form a bond. Nitrogen donor, carbon acceptor. Now final structure you will get, that is isocyanide structure. A critical molecule, but remember this structure when I will go to reaction, organic reaction, then you have to draw the mechanism, and to draw the mechanism of the reaction you have to know the clear idea about the structure of isocyanide. This is isocyanide, NC. Here the valency of nitrogen 4, that's why formal charge plus 1. Dear students, I have taken here 2 important examples. One is BF4 minus BF3. BF3, boron has 3 orbital 3 electron. 3 orbital 3 electron form bond. 1 2p orbital is vacant. It is less than octet molecule. Effective number of electrons around boron you will get 6. That's why it can easily form BF4 minus radical. F minus will donate electron, pair of electron, and boron acceptor. And you got the structure of BF4 minus with octet. Boron has octet. But here see, here minus charge on boron without any pair of electron. Remember, without any pair of electron. That's why although it is minus, never acts as nucleophile. Another I have taken here, diazomethane. CH2 radical I have drawn here. 2 sigma bond, 2 electron. I have kept here in a single orbital, 1 orbital is vacant, and nitrogen electron pair donor, and you got a molecule where nitrogen donor plus charge, CH2 acceptor minus. You got the structure of CH2N2, that is diazomethane, complicated structure, and I have drawn here another canonical form of diazomethane. Remember this canonical form more stable, since here minus charge on carbon, here minus charge on nitrogen. You know minus charge on electronegative more stable than electropositive. You got important structure of diazomethane, which is an important reagent in organic chemistry. Thank you all. Stay with us. I will give another examples by taking hybridization as well as molecular orbital theory concept.